Today we're going to talk about the Big Tree Tech SKR version 2. Now I've made two tutorials on this that I've had to obviously update because changes have occurred between them. So what I'm going to do is talk about the board real quick and what's laid out on it. So the first thing that I want to talk about on this actual board is the actual parts that you'll be working with most often. I probably won't cover everything when I outline the board, but I do have a playlist of tutorials that I'll link in the description. So to start with, we have our steppers. We have our X stepper, then we have our Y stepper, then we have our Z stepper, and we have our E0 stepper and E1 steppers. So these are your first and second extruders. Also, we have several addressable fans that we can use to control power. So we have fan 0, 1, and 2. Over here we have two extruders. Now I've marked it with red and unmarked for voltage and ground, but generally with extruders you do not need to worry about the actual power supply, but there is an exception if you're using a relay. But in this case, I'm just going to stick to the simplest tutorial part of that when I talk about it. Over here we have our board power, so I've marked it with red for voltage and unmarked for ground. It can either be 12 or 24 volts for the board. Then we also have our bed logic, so we have either 12 or 24 volts that we can use for this, and red is marked for voltage, and of course unmarked is ground. Over here we have our USB connection. This is universal serial bus, so if you have a direct connection from either your computer or maybe a Raspberry Pi with Octopi loaded on it, you can use it for that. Also, you can possibly use it for Clipper as well. Over here we have the way that we load the drive, which we use an SD card for. And above it, we have these little ports that we can use for a Wi-Fi module. Over here we have our jumper pin. And currently, I am using it for either direct power or USB power. One of the ways you can check it is by actually plugging in USB, and if you get nothing, that means that there is no 5 volts jumped. So you can move this over and actually jump it to 5 volts and power your board. Now, it's not suggested to use this in the case of using TMC type steppers, as it will cause precision issues. Now, back to the actual steppers over here, there's a couple more functionality that I have not talked about. There's closed loop steppers that you can attach with these little pins down here. I personally don't use them and probably never will talk about them other than now. But let me show you what the actual end stops look like, because this can be slightly confusing. There used to be what's known as X minimum, X max, but they've changed it around, so you have Y minimum and then you have Z minimum. These are now used for filament detect on the first two for the X max and the Y max, and then the very third one is used for power detect. So basically they're using the ground and voltage pin as well as the signal pin to run those devices. Now we also have our EXP1 and 2 ports. Now I've got them in reverse order because it's actually EXP2 and 1. And essentially what those are for are legacy displays such as the RepRap full discount controller for a display. Now there are other types of displays that you can use, such as the TFT display, which the pins are down here for it, and that'll allow you to use touchscreen mode on your display as well as legacy mode for the old Marlin displays. Now there's other pins down here that I'll talk about a little bit. We have the pins for your servo right here, which are down in here, And then we also have your BL touch pins that you can use, or you can use your X minimum as well for your end stop. Then we have other pins for our thermistors that are located down in here. So give me a second to actually sort these out. We have our PS on pins right here. Then we have our TB, or this would be the thermal bed or thermistor pins. Then we have our two extruders, which would be HE0 and HE1. Then we have a drive connection here for USB. I'm not sure exactly how to run that just yet. And then we have other pins. We have these 4 pins that I need to identify, but I believe they're the I2C pins right over here. So you can use certain types of things like a blink display or other things that you choose to connect that use the I2C configuration. So moving along on here, I have to also point out that there's a difference between the actual SKR version 1.4 and that now they don't use the car fuses. They actually use these tiny fuses down here. And they also have a different processor. So it's no longer the LPC 1768, or in the case of the turbo, the LPC 1769. They're actually using the same processor, essentially, that you're using on the SKR Pro, which I believe is an STM32F, to run this board. So it's a more powerful processor than the actual turbo. So what I want to do now is actually show you how to set this board up. So in the basic tutorial, essentially I show you how to walk through the board. I don't show you all the functionality because it would take forever. So I'm going to pop out the SD drive, which in this case I'm using an 8 gigabit drive, and I'm going to put this in the actual USB converter and connect it to the computer. So you may hear a beep. And then there's one other thing I forgot to point out about the steppers besides the actual stepper driver types. Down in here, they actually have the jumper for sensorless homing. They're 2 pins, and they actually use the 2mm jumper caps instead of the 2.54mm jumper caps that you have over here. And the stepper drivers, by the way, are actually, you have a choice of either the A4988, which is a step direction stepper, or the DRV 8825, which is the same. And then there's other various types of TMC type steppers that allow you to use stealth chop or other things that you so choose. So there are some fan ports that are direct power up here that I didn't point out, being 12 or 24 volts based on your power supply. And also you have an additional opening over here for a second stepper on your Z-axis. So there's a NEMA 1 port and a NEMA 2 port. So moving on to the actual firmware and how to set it up, I'm going to take you over to my desktop on my computer and show you the board. Now, a lot of things that I might not have covered because there's more detail here are the actual signal pins. So as you can see, we have 3 fan ports and they have signal pins associated with them on one side. The same goes for our step pins. And these are important to know what they are because in certain cases you may have to hook up something special and know what your pins are. So what I'm going to do now is actually show you the Marlin firmware that I downloaded. The current version that I downloaded as of today is 2.0.9.1. And as you may have seen in previous tutorials that I've done, it does change, and that's why I have to sometimes update my basic tutorials. So I'm going to right click on this and click it to extract. And this should extract in a few moments. So while that's extracting, I do want to talk about the board. In the case of the early released boards, there was an issue with MOSFETs. Some users have pointed out that the reason this occurred was due to COVID, which is possibly true, but they substituted the wrong MOSFET. Make sure in the description of this tutorial, when you're using TMC type steppers, like I've outlined in my stepper tutorials, that it's the right MOSFET. Otherwise, there's a way to replace it per Big Tree Tech. So, now that we have this extracted, I'm going to go over to VS Code, and I'm going to open this up. And to open the actual file that we just extracted, I'm going to click on the Explorer over here. Then I'm going to do Open Folder. Inside here, I'm going to go to my Downloads folder, then the Marlin folder, then the next Marlin folder, then Select Folder. What'll happen is it'll open it up to platformio.ini, and keep in mind that right now it's set to the Mega 2560. So I'll show you how to adjust for that. So if you go over to the Marlin folder over here and then configuration.h, this is your configuration, but we're going to have to set it up in source first. So we're going to go to source, core, boards.h, and we're going to search on skr_v2. Now there's two versions of the board. The corrected MOSFET board is actually Rev version B. So I'm going to copy this and I'm going to close out of boards.h. Then I'm going to go over to the actual configuration file and search on Marlin, or motherboard in this case, pardon me. I'm going to highlight the ramps, that was the legacy configuration, and paste over it with our version of SKR. Then I'm going to scroll up and change the serial port to -1. And some of the changes that you may not have noticed is that there's an additional serial port now in the newest version of Marlin. And they've also created the ability to control the baud rate. So if your TFT display runs at 115/200 and you don't feel like adjusting it, you can always adjust it in the Marlin firmware. But that's another tutorial. So for now, what I'm going to do is I'm actually going to show you how to build this. So it's slightly different. So if you go over to the Marlin INI, you're going to notice that there's a bunch of INI files. One of the issues that you're going to have to figure out is which one to use for your chipset. Now, I've already told you what the chipset is in this case, but one way to identify it if you're using possibly a different board is to go over to boards.h and search for your board over here, and it'll say STM32F0 in this case. It goes on a little bit more, but obviously that'll help you understand which board you're using. So I'm going to minimize that for a second and actually finish off the INIs. So over here I have to find the actual INI, so it's STM32F, and then I have to search on SKR_2, and here's our actual default environment. So I'm going to copy that, minimize it for a moment, go over to platformio.ini, and then paste it over the previous configuration so that we're all set there. Now I do need to point out the pins file. So I'm going to go to source, pins, and then I'm going to find the same board chipset being STM32F, and I need to point out something relevant. So you see how it says BTT SKR version 2 Rev B. This points to a common file. That's associated with our pins that we saw on the pinout diagram earlier. So the common file in this case is going to be all our pins outlined for us as we saw down here. So they're just setting up where things are located so that when it builds, it knows what to communicate with. It's essentially a database of pins. So now that we have that all sorted out, I'm going to show you how to build it. Now there's obviously two ways to build it that I showed in a previous tutorial with the actual build environment with Marlin. I don't like showing this method only because you have to do a clean first, but in both cases you're gonna have to do a clean first. So I'm going to go over here and show you what's going on. Up here, you see how it's displaying the ramps? The reason that's occurring is because in .pio for build, the previous build was the Mega 2560. The reason that is because they like to confirm that it works with their default platform before they release it, so it's still an artifact of a previous build. To clean that out, we can click on the garbage can over here, which is clean, and that'll take it out and then change this to our environment by reading our configuration.h file. Now we can build here by clicking the build button, and that'll take care of it for us, or we can do it with the checkbox down here. My preference is the checkbox because the build will take care of the multiple compiles that we're doing. So in a moment, it's going to pull down the build that we're working with, and it's going to start to build it. Inside here, you can watch it as it builds, but if there's an issue that occurs where you build and it fails, try building a second time with the checkbox, because on occasion, files will build out of order, and the second time through, it may take care of it. If through the second time it does fail, find the very first thing that failed, it's usually in red, and correct that issue, because all issues that occur after that red mark for the first time it fails in here are probably a cascade of issues related to it. So in order to set this up so we can load it on our actual drive, we need to go over to firmware.bin, right click, and then say reveal in File Explorer. So we see it right here where it says firmware.bin. Now if you've loaded a build before like I have, you'll see firmware.cur in capital letters. That's actually firmware.bin that's been renamed. And the reason that they rename it in all capital letters in cur is because every time you power up the board, if it has the lowercase firmware.bin, it'll reload the firmware. So this is a way to prevent that on the second time through after you've loaded it. The actual file type does say cursor, but it's actually not a cursor file. If you were to rename it to firmware.bin, you could reload it again. So I went back to the folder and I'm going to right click and I'm going to go to send to and send it to the boot drive where we have the cur. So this file should load and then rename itself to this. So let's give that a try. So over on the desktop, I'm going to pop out the board. I'm then going to place the SD card inside the drive. And we're set, I believe, on USB power, but it may not be. So we can test it by plugging in the USB. So right now it's actually loading the firmware, as you can see over in here with the flashing light. And that beep says that it's connecting to your computer. So to test this, we can actually go over to Pronterface, and inside Pronterface, we can actually connect to our board. In this case, we see COM port 1. One of the issues with that is that we need to know what we're connecting to. So I'm going to click on the start and type device manager, and it'll pop up on, unfortunately, my other screen. But you can see, once I drag it over, that the actual port in this case is COM port 4. So I'm going to close that down. I'm going to see if it's in the drop-down. If it isn't, I can always edit this. So let's see what we've got. So it says 13, so I'm going to click on the actual edit here, backspace, change it to 4, and then I'm going to connect. Now you can see that I'm actually connected over here to the actual board. So one of the things we can do that I like to do is actually test to get a response back from the MCU, which is the processor in the center of the board right here. It's going to reply back through the wiring and let us know the answer that we're looking for from the firmware. So to do that, I'm going to type M119 to check the end stops. Now, since there's no end stops connected, they're all going to say triggered in theory. So I'm going to click on it and see what happens. So in this case, it does say they're all triggered. Now, keep in mind, there are other firmwares that you can load, such as Klipper, which I may cover in a future tutorial, but I have already covered it in the Octopus version of Bigtree Tech. So the process is slightly different for setting it up in the actual environment. But if you need a template to do it, that's a good place to start. So if you like my tutorial, please press the like button and subscribe. And for those patrons that are out there that want to see early looks on tutorials, I'm posting them there first before everyone else can see them. And for the people that have been paying me on PayPal with tips, thank you very much. It's greatly appreciated, and it helps offset the cost of these tutorials. So if you haven't had a chance, please like and subscribe, and take care, and thank you for your time.